Hello, everyone. My name is Raihan Khan. I am here with my colleague, Dr. Catherine Zeman. We are from the Department of Health Sciences, James Madison University. Together today, we are going to explore how AI, or artificial intelligence, can shift from being an environmental burden to a net benefit for health and environment. Next slide, please. So let us look at this slide. The critique of use of AI and the burden. I mean, there are a lot of discussion about it. If we think about how AI is being produced, we need for large scale models, which our previous speakers shared, ChatGPT, Copilot, Google Gemini, they need huge data centers. And Microsoft, OpenAI, Google, Meta, they are making a lot of data centers throughout the world, especially in United States. Now, these data centers need top-notch and power-hungry GPU, which are the processors where AI is actually, the system is thinking. So every time they're working, every time we are inputting them any information, they are generating tokens. For each token they generate, they are power-hungry devices. They need a lot of electricity. With electricity comes additionally heat, that is a byproduct. To reduce the heat and keep the machines running in a optimum temperature, we need to cool the device down. How do we do it? One option is to use fans, and also they need water as a coolant. As a result, there is an estimate that by 2030, the entire world will need around 45 trillion watt-hour electricity per year to feed these big data centers. So that's a big challenge, and these are some of the critics. Plus, we need to remember that when these data centers are working 24/7 with those big, powerful computer system and a lot of fans, they generate a lot of noise, which is a big noise pollution for the people living near those data centers. And the water they're using, they're also very power hungry. So we're using a lot of water, valuable water, which is actually a limited resource in the world. So these are some of the critics of AI. So let us go to the next slide. So what is happening actually, that some companies and organizations are trying to reduce this wastage. So some of the responsible environmental practices that have been done or have been proposed. So let us look at some examples. One of the large companies that have invested billions of dollars is actually Microsoft. So Microsoft has been trying to use recycled water to cool the data center. So thus not using the potable or water, which are clean water, instead using recycled water, reducing the water demand. In another case, they have used non-water cooling methods. So that by doing that, they are saving the important water resource. For example, another example can be given for European countries. For example, in Germany, what they have done is that they have used the water after, which is used as a coolant there. So when it is used as a coolant to get the additional heat from the data center devices, they are becoming warm or hot. And that hot water they're using there in Europe to heat the homes during winter time. So that is very ingenious way to recycle the energy. So these are some of the examples. So let us go to our next slide, please. Now let us look at some approaches taken or have been proposed. Some bills, policy regulations have been proposed by governments or organizations. For example, in United States, in New York State, there has been a bill has been proposed for renewable energy target to be used by data centers. So they are saying that in that bill, they propose that in New York State, by 2050, the data centers for AI should use renewable energy 100% by 2050. In Virginia, our home state where our university is located, there is another bill that has been proposed. It hasn't been passed yet, to my knowledge, that similar idea, mitigating energy, water, and land use to reduce the impact of rapid data center expansion. There are some other organizations, environment-friendly organizations, and other states are trying to bring some bills and policies to reduce this burden of burden on environment and resources. Let's go to the next slide, please. Shallow use of AI. What does it mean? Like, if we are not utilizing the huge potential of AI, we might be using it wrongly. But on the other hand, we might be using it wrongly, plus we are utilizing the resources to run the devices. For example, AI can be used only as a glorified search engine, which is actually very common. And in the next slide, we will show you an example from a recent study, how AI, a lot of people, including our colleagues in academia, we might not be using AI to its fullest potential. Yes, thank you for the next slide. In this slide, we can see a recent article actually is showing that according to their estimation, up to 40 to 50% cases, we are using AI, this ChatGPT, Copilot, or Gemini only as glorified search engine. But as I said, in the background, for every question I'm asking the ChatGPT to run, I am utilizing a lot of energy. I could have saved that energy by doing basic Google search in my cell phone or in my PC, but not using not using AI. I do not need to use probably AI to run a easy math that I can do in my basic computer or my calculator, even in my calculator in my cell phone. So up to 50% of cases are utilized this simple way. Up to 20 to 30% of cases, according to that research, we are using AI in a little bit more moderate complex works. For example, maybe summarizing articles, feeding multiple PDF files from multiple researchers, and asking ChatGPT or Copilot or Gemini to summarize or give us a brief idea. Only in 15 to 25 cases, people are using AI to its fullest potential. For example, generating hypotheses, asking the AI to generate models, and trying the models, doing the simulation, utilizing those models in pilot study, feeding the data back to AI, and maybe getting the revision or more complex thinking process, utilizing only for 25 to 15 to 25% cases. Next slide, please. As I said, the shallow use is a problem. In another study, they have showed that Claude, which is one of the widely used AI system, up to 50% of cases, the AI was used as an augmentation, not for any potential, not utilizing its fullest potential. So we are actually losing those benefits, and we are actually utilizing the resources in a power-hungry way without getting the fullest potential. We are utilizing or wasting our limited resources. And not a lot of countries can actually provide that much resource. Even in larger countries like United States or some other wealthier European nations, this has actually become a huge problem and burden. For example, utility companies like electricity companies are trying to charge more to the regular people for the use of electricity, because they have to produce a lot of electricity for these AI data centers. For example, in our home state, Virginia, the largest electricity provider is Dominion Energy. Dominion Energy recently proposed a bill hike for regular population, regular citizen in Virginia, and that is one of the largest bill hike they proposed to the government in the history. One of the reasons is that they have to produce a lot of electricity for these power-hungry data centers. And Virginia, near the Washington, D.C., near the capital of United States, we are one of the largest hubs for these data centers. So let us go to the next slide, please. So what other ways, alternative ways, can we utilize AI to its fullest potential? Some examples. We can utilize AI to predict weather, several days of weather prediction using AI, and that modeling can be done very nicely, precisely. Up to 98% of cases in one study they have done that the AI models were able to predict AQI, means air quality index. So that means predicting what would be the air quality in a geographic area. In another example, in Beijing and Hong Kong, two large metropolitan areas with a lot of people and also highly industrial areas, a lot of pollution, AI models have been used to predict to predict high resolution pollution mapping. So these are some of the examples where we can utilize AI to its fullest potential. Next slide, please, Dr. Zeman. So what we are proposing is that we should utilize AI in a dialectic supercharged discourse. What does it mean? If we look back in history for several thousand years in Western philosophy, if we remember Aristotle and Plato and Socrates, it's actually not a new idea. It's an older idea. We can think about Socrates. Actually, he was the father of this idea, the dialectical process where multiple speakers are talking to each other, asking questions to each other, generating hypotheses, fixing each other by asking questions. So this way, we can help each other. We can utilize AI models to put into this dialectic discussion and generate hypothesis and modeling. Next slide, please, and we will show, yes, our basic workflow. We can feed data to AI, and AI can produce us or give us some modeling, generate some modeling, utilize those models or hypotheses. Modeling, we can generate several hypotheses. We can simulate those hypotheses into AI, or we can do pilot a stage prediction or experiments in real life, feed the data back from those experiments back to AI, and we can improve those modelings for real life implication. In the next few slides, Dr. Zeman will discuss some of those examples that we have done recently.
Great. Thank you, Dr. Khan. I appreciate it. And as Dr. Khan was pointing out, we wanted to discuss in this presentation the way in which AI could further environmental and environmental health benefits while being honest about the environmental challenges and what needs to be done to move AI into a net benefit for the environment. So just giving some examples, as he was pointing out, the way it's been used really that would impinge on environment and health so far is in the climate modeling, air quality index, weather prediction area, which is important, but we think that it could be used to do much more. In particular, some of our environmental health and public health work is in the area of toxicology. And one challenge in toxicology is modeling complex exposure scenarios. It could also be applied to various activities that are part of everyday work that needs to be accomplished in public health departments. And we think particularly the benefit of AI with good data input, of course, is in its ability to run a number of modeling projections. They can work with a wide range of statistical and computational models, as you see in this slide. I don't want to read every one of them off, but obviously they allow us to look at data and project from multiple data streams what impacts will result as a result of interaction between the individual data inputs. And so some of the things that we might be doing in a public health setting, environmental measurements, biological data, health data, demographic data, and policy scenario intervention data can be layered together to model situations of importance to public health and environmental public health. And by aligning exposure data, biological responses, and model predictions, AI can generate these insights for us that help us to take things from field experiments to laboratory, or from laboratory to field experiments. So let's just take a look a little bit at the aspect, task description, overall impact of human processes, environmental cost management, time labor savings, and relative benefits, right? AI can take this routine information that's gathered in environmental and public health settings, take it into a structured, data-driven process that will help strengthen our research, our education, and our outreach, because the environmental public health settings, not only are there individuals performing research and providing information that informs practice in public health and ultimately impacts medicine also. So that kind of applied work could be very, very beneficial. And if you start looking at the post-development energy and water costs, so following development of the AI, the cost of an individual query drops significantly. So the water and electricity costs end up dropping. And if you're using the AI to generate reports, community needs assessments, et cetera, you're saving a significant amount of time. If you use the expert as someone who can identify and feed in quality data sets to the AI can provide us with some statistical computing power that is well beyond what most people would have had available to them at a county health department level, or even at some state health departments. So this could be saving a great deal of labor. If we take a look at the information that was in that chart, kind of plotted on a bar graph here, you can see the human-only approach, where the energy use, time, and analyses completed is compared to the AI-assisted workflow. And what ends up happening once model development is accounted for, so everything it took to generate and create Claude or ChatGPT or Copilot, et cetera, once that's all taken care of, then really the energy and water costs drop dramatically, while the productivity profile per worker and the amount of engagement that can occur increases dramatically. And I think this is something that we have been interested in illustrating for other people in public health and in environmental health science research. So let's take a look at two examples. I mentioned that something that is commonly done in our laboratory is looking at the interaction of multiple toxins as they interact together. And what I actually did is I used AI to take information from one of our already published papers and then to look at some just table level findings. So it was basically able to use the Bayesian modeling to give us a prediction of how two substances that we have studied in an immunotoxicology setting might interact. And then we can develop means of actually testing that model. So you see, we were looking at the effects of nitrate exposure on lymphocyte cytokine expression. These are chemicals that immune cells in your body called lymphocytes secrete when they encounter various substances. This substance happened to be nitrate. We had also been studying the effects of cat's claw, which is an herb, on lymphocyte proliferation and nitrogen oxide expression for other reasons. So what if we layered those two sets of data together? What kind of interaction effects would we expect to find? And of course, if we can do this in the laboratory, you can do this in a community where you're looking at health risks in a community. Now, depending on the type of data you're able to input, if you can input the primary data sources, you can get some real detailed estimates. So using tables, right, from our papers, we could get some very detailed estimates. If you're inputting just information about like there's a more dichotomous, you're going to get more of a general probability model. But it is nonetheless useful in either situation, and it's done very quickly. So in this particular situation, again, I input just the data tables from these two papers. In the one paper, the nitrates encouraged pro-inflammatory factors. In the other paper, the cat's claw, Unicaria tomentosa is just the scientific name for cat's claw. It's an herb that people take to help relieve inflammatory pain in their body. So the assumption is that an anti-inflammatory effect would ensue. And of course, we can pose the research questions. Proposed statistical models will be examined. We will study the best models based on what we had. Bayesian dose response modeling, Emacs or SPLINE models was the best, since I was basically feeding in just data tables and not real-time data. In other words, the detailed databases themselves, I just didn't do it for this example. When you look at the two questions that were posed, does nitrate exposure alter nitric oxide and cytokine expression? Does cat's claw supplementation modify nitric oxide expression or viability compared to control? The analysis was that both cytokines respond linearly to nitrate dose, showing a clear pro-inflammatory trend. Now, this is modeling on the part of the AI, increasing exposure, validating nitrate reactivity in vitro in glass studies in the lab. Cat's claw appears to buffer nitrate-induced oxidative inflammatory responses by improving nitrogen oxide regulation and reducing response variability. So basically, there would be pro-inflammatory trends with nitrate reactivity in this model. And in this one, the cat's claw would serve as a buffer. Now, we've never ran these experiments in reality where we mixed nitrate and cat's claw. So what else could we do? We could go in, do the experimental design, set up some immortal cell lines in the lab, expose them to the treatments, no supplement or to cat's claw treatment, and under varying nitrate doses, and it can give us the estimate of what we might find. Then you can test that in the lab. These are very useful tools and can definitely improve practice in the lab, and should certainly be able to improve practice in settings, in public health field settings, where individuals are gathering data and doing risk assessments for community. The AI is able to create and provide a Bayesian probability distribution model of the highest risk in the community. They can do it in a number of hours, and that can then be checked by the public health workers. Of course, you have to always be aware of reliability checks. So cross-model comparisons, triangulation with the known literature, sensitivity analysis, and obviously you need human experts providing the model with quality data. And that has been one of the key situations. You need to make sure you're choosing the statistical model appropriate to the situation, and that as the human working with AI, you're making sure that that is occurring. And you need to be aware of some of AI's challenges, right? Perhaps everyone has experienced model degradation, where you're working with too much complex data and you have to step back, clear out the fields, and detect when the AI is going into sort of a model collapse situation because it's overloaded. And then there's also always the concern about confabulation. I was chuckling to myself that Claude in the previous presentation was kind of being the confabulating class clown in that test, but they can do that. Obviously, it depends on how wide the original prompt or query is. If you're controlling the prompts and queries very narrowly and controlling the data that you put in, my understanding, and having checked in the literature, is that the opportunity for confabulation is very low, zero, really. But if you leave very open-ended questions and you leave the AI to just create this for me, you're going to get a 50 to 70% confabulation rate. So just have to be aware of those types of concerns and issues. And of course, the energy and resource costs are always back there and often in our minds when we're talking in environmental public health circles. But there are a number of approaches that people are taking to improve that. I'll show you that in a slide in just a minute. This is just a model of the types of benefits that could actually accrue in public health settings in regards to savings of time, increased opportunities for understanding interactions between variables that could affect environment and health issues, and furthering research and allowing you to run models and then look for signs in your actual research experiments that either validate or reject those models. Finally, kind of want to wrap up with the idea that there are solutions that are being actively worked on to deal with the problems related to energy and water use. So climate change AI, the Bezos Earth Fund, Microsoft AI for Earth, the Green AI Institute. In fact, some of the projects that Dr. Khan talked about earlier, they're being funded by these entities and agencies. And so to wrap up, AI becomes a real ally to both health and the environment when it's deployed responsibly, transparently, and in partnership with human expertise and quality data. And this just is a summary of that. When that is occurring, then we can get into these situations where we use the best of the dialectic approach that allows us to generate new insights. And another thing maybe encountered a little bit with colleagues or with people in the field, that using AI is not cheating. It's actually incredibly beneficial and allows you to be more productive as long as it's used responsibly. And it should not either be just a simple search tool, although its ability as a probability calculator is amazing, right? It will expand our capacity. So we just want to thank you for your attention, and then a few of our references that we used in the presentation.
So thank you both for the very interesting talk. I mean, health and environment are very important fields, as we all know, and they really gain importance in our world and need to be addressed. And it's really nice to see this, and then important to see it in the context of usage of AI. So I guess there might be some questions. We have a comment, fascinating stuff. Yeah, I completely agree. And actually, I had a question, but you already answered it. It's like fixes and tips in the usage. So that was very helpful to see, to bring it to the point, what to do and what to consider.
Yeah, it's very interesting that if people approach the AI with just those kind of very broad, open-ended queries and commands, right?